Ever pondered about how we weigh atoms or molecules? It seems like a peculiar question, right? But it's one that chemists deal with regularly. The answer lies in a concept called molar mass. Imagine a baker needing a specific amount of flour for a cake recipe. But instead of grams, the recipe calls for a mysterious unit, baker's dozens of flour. The mole concept introduced earlier is like that baker's dozen for atoms and molecules. But how do we weigh such a vast number of tiny particles? This is where molar mass steps in, providing a bridge between the microscopic and macroscopic world. First, what is molar mass? Molar mass, denoted by the symbol M, is defined as the mass of 1 mole of a substance expressed in grams. In simpler terms, it tells us the weight of a giant collection of atoms or molecules of a particular substance. So, how do we calculate molar mass? It's a 3-step process. 1. Find the atomic masses. Look up the atomic masses of the elements involved in the molecule from the periodic table. 1. Multiply and add. Multiply the atomic mass of each element by the number of atoms of that element in the molecule. Then add all these products together. 1. Units, don't forget. Since atomic masses are in atomic mass units and molar mass is in grams per mole, the final answer will also be in grams per mole. Why is molar mass important? Molar mass plays a crucial role in various chemical calculations. It allows us to convert between the mass of a sample and the number of moles it contains. It helps ensure we use the correct quantities of reactants during experiments or industrial processes, and it's essential for performing stoichiometric calculations. Molar mass is a fundamental tool used in laboratories worldwide. For example, a chemist might need to know how many grams of sugar are needed to prepare a specific volume of a solution. By calculating the molar mass of sugar, they can determine the exact amount needed for the experiment. While the basic concept involves adding atomic masses, molar mass calculations can become more complex for molecules containing isotopes or ionic compounds. However, the core principle remains the same. It's the weight of a massive crowd of tiny particles, allowing us to work with the invisible world of atoms and molecules in a tangible way. So, the next time you see a chemical formula, remember, the seemingly simple numbers behind it represent the combined weight of trillions of atoms, held together by the invisible forces of chemistry. Molar mass helps us bridge the gap between the microscopic and the macroscopic, unlocking a deeper understanding of the world around us.